Welcome everyone. So today's lesson is TOC 5-9. So you guys should have 5-9 either open on your screen or you should have it printed out if you're able to do that. So either way is fine, but really try to take notes, write down the problems, do some on your own. And all right, let's get started. So today we're talking about standard form, vertex form, and factored form. And you guys have seen all three of these. So try to think back and think if you can remember an example of standard, vertex, or factored form. All right, let's go. So, okay. Ooh, that is not what I wanted. Okay. So your warm-up right here is a parabola, and then you need to label it. All right. So feel free to give me a pause and come back to it when you guys have done it. If you just want to sketch it out on your notebook, like if you don't have it printed out, that's great too. All right. So if you're back with me, the first one says label the x-intercepts, the y-intercepts, and vertex on the parabola. All right, so the y-intercept is where it crosses the y, all right, axis. And so that would be right here. All right. Okay, so right there at where x is 0. Remember, x is always 0 at the y-intercept, and y is -9. All right. All right. So that's a -9, even though it's kind of sloppy. Okay. Now, x-intercepts. Again, that's where it hits the x-axis. So we've got two of them. One is right here. And remember, the x is a number, but the y is always 0. Like if I look at this point, right, I would have 3, 0. And my second x-intercept is right here. So same thing, I would have that's -1, -2, -3, and my y value would be 0. All right. Now the vertex is the lowest point or the highest point. So in this case, I see the lowest point is actually the same point as the y-intercept. Now, that's just a coincidence, but that that vertex is also 0, -9. That's a little bit better of a -9. All right. Okay, describe how the graph transformed from the parent function. So if you guys remember, the parent function always has a vertex of 0, 0. And I'm just going to sketch it out. So it's not going to be perfect, but it's something, oh, that's really sloppy. It's something like that. So the vertex moves down 1, 2, 3, 4, 5, 6, 7, 8, 9. So it moves down 9 spaces. Okay. Now, if I'm writing an equation for that, I am going to say y equals, and now remember, I always compare it to my parent function. And the parent function for a quadratic or a parabola is y equals x squared. So I'm just going to say y equals x squared minus 9. And that shows the transformation of down 9 spaces. All right, explain how you know your equation works. I'm not going to write anything down, but your answers could be something like, I plugged it in the equation, right? And I got all of these points, the 3, 0, 0, -9, and then -3, 0. So not only is it the shape and it looks like this one, but you can also check those points. Okay, again, feel free to pause me if you need to write down your notes or go a little bit slow down. Okay, So here we go. You can have your standard form, your vertex form, and your factored form. What you need to know is all of these can be the same equation. You can just write it in all three different forms. So any quadratic equation that you get, y equals x squared plus 2, y equals negative 5x squared minus 5x plus 5, right? Anything that is a quadratic equation, which has the highest exponent of 2, can be written in all three forms: standard, vertex, and factored. They're just different ways of writing the same equation. Just like we've been working with greatest common factor, when you factor out the greatest common factor, you still have an equivalent expression, and that's what these are. So, standard form is something that we've talked about, where it's just written in the order where the highest exponent, so oops, all right, well, I kind of blurred that out, but that highest exponent is written first, and then the next highest exponent, right, so this would be 5x to the first power, and then if you see here, there's actually no x, so it's just the order that it's written in. If I have an equation that's in standard form, it's just super, super easy to find the y-intercept, because if I made both of these x's 0, right, then 0 times anything is 0. That would cross these guys out, and I would know that my y-intercept is negative 2. All right, and that's always the case. So standard form just makes that y-intercept super easy to identify. All right, vertex form. This is the form that we always put it in when we're talking about transformations. So if you notice this negative right here, right, that negative right there, all right, that means that it will flip upside down. This 1/2, all right, I'm just going to underline it because I can't get this. The 1/2 makes it wider. The negative 3 would move it to the right 3 spaces, and the plus 2 would move that vertex up, or actually all the points up 2 spaces. So whenever we're talking about transforming from the parent function, that form is called the vertex form. And if you haven't noticed, there is always going to be a correlation with this 3, let me do a different color, with this number inside with the x, and that is the x value for your vertex always. And then the number outside, let me do a different color again. The number outside right here in yellow, that is always your y value for the vertex. So I don't even need to plug this equation into my calculator in order to know that the vertex is 3, 2. All right, so factored form is the last one we're going to talk about, and that is a form where we take a bigger expression and we break it up into little parts that we can multiply, that will give us an equivalent expression as the original. All right, so if you notice, I have 3 little parts to this. I have 2, x plus 1, and x minus 2. Now, x plus 1, I'm really trying to make the y value as 0. And we're going to go over this a little bit later. But negative 1, right? If x is negative 1, negative 1 plus 1 is 0. Okay? And here I have x minus 2, and if x is 2, 2 minus 2 gives me 0. So factored form just allows me to really quickly identify the roots or the x-intercepts of a parabola. All right, so let's do this first example together. All right, if you notice, it is in factored form. I've got 2 pieces, right, x minus 3, and x minus 1. So without even graphing it, I know on my x-axis that at a positive 1, because 1 minus 1 is 0, yeah, okay, and then at a positive 3, so 1, 2, 3, oh, this is a tiny one, okay, so I know that those are going to be points, but let me just check it out. So get your graphing calculator and just put that in. Again, feel free to pause this. I'm just going to say x minus 3 parentheses x minus 1 parentheses. Okay. So when I look at my table, I see that I've got some points. And I'm actually going to write the table out in green here. So I'm just going to write out some points that I'm drawing. All right, so I see 0, 3, 1, 0, 2, negative 1, 3, 0, and 4, 3. Okay, so again, I just put y equals x minus 3 times x minus 1 in the calculator, and the green table are the points that I got. So I am going to, first of all, just check, did I make the right red points, the x-intercepts? So I'm looking for where y is 0, and here, yes, I see it at a positive 1 and a positive 3. Excellent. All right, so now let me plot those other points. So 0, 1, 2, 3. Okay, I already got this point. 2, negative 1. Oh, so it looks like we have a minimum going on here. And then 4, 3. Let me see if I can fit any other ones. I have 5, 8. Does this go up to 8? 3, 4, 5, 6, 7, 8. Oops, that's my counting. Sorry. Let me erase that. Okay. All right, so I have 5, 8, and negative 1, 8. All right, so here is, and remember, you need to go all the way to the edge of the graph or do the arrows. So I'm just doing both to be extra cautious. All right, so my x-intercepts are where I have 1, 0, and where I have 3, 0. Okay. Now the vertex is that minimum point right here. So that's your vertex. And that is negative 2. Oops, sorry. Positive 2, negative 1. All right. So this one right here. So positive 2, negative 1. All right, and my y-intercept, again, that y-axis. So I see that that point is right here where x is 0. So that is 0, 3. All right, and then I'm going to choose another point. I guess I can just choose anything. Let me put in 4, 3. Okay, just because I see that here. So any other point, cool. All right, so now we're talking vertex form. So here I can easily tell you that my x value for the vertex is 2 and my y value is negative 1. All right, so my vertex is going to be 2 and my y value is going to be negative 1. So 2 and then negative 1. Is this the same graph that we did before? It could be. All right, so I'm just going to put that in my graphing calculator. Again, feel free to give it a good pause. Come back to me when you're ready. All right, if you're still here, I am putting x minus 2 squared minus 1 in my calculator and doing the table. Okay, it looks like this is actually the exact same equivalent parabola, right? The same quadratic function as example 1. So that's a great example of the fact that it looks super different, but this is actually the very exact same. So when I do my points, and I'm going to actually start with -1 this time. So it's -1, 8, 0, 3, 1, 0, 2, -1. There's that vertex. 3, 0, 4, 3, and 5, 8. All right, so let me just plot that really quick. So -1 all the way to the top. 0, 1, 2, 3. 1, 0. 3, 0. 4, 3. Yeah, all right. And 5, 8. All right, let me just erase that. Okay, so this one, I'm actually just going to take this and I'm going to go to the top of the graph. So that's fine too. You would get full credit on the regions. It's only if you don't go all the way to the end. All right, so same thing. I look at my y-axis and I see right here, and this point here is 0, 3. So I'm going to put 0, 3. And my x-intercepts, right, are where I hit the x-axis, and I do it here and here, right? So let me just put those in. That is 1, 0, and 3, 0. And now it says just choose any other old point. So let me choose a different one. Let me say, all right, I'm looking actually at my screen. Let me do 724. 724. So I'm just looking at my calculator screen. All right, and that is vertex form. So again, I can easily just look at this equation and know, hey, vertex form, my vertex is at 2, -1. All right, and it is weird because it looks like a -2, but remember when it's inside of the parentheses with the x, it's the opposite sign of what you would think. Whereas the -1 outside, that's always +1 means you go up 1, -1 means you go down 1. All right, but the x -2 actually means you go right 2, so that's a +2. It's a little tricky. That's why practice is so important. Okay, so let me look at this one. This I can already tell is different, right? So I see that negative in front of the x squared, and I know it's going to be turned upside down. All right, so standard form, I know if I were to take out both of these guys, right? If I were to take out both of those, so if x is 0, my y-intercept would be -5. So if the x's were 0, my y-intercept would be -5. All right, so let me erase it so I can see what was here again. So take a minute, get your graphing calculator. I hope that you downloaded those apps onto your calculator. Look at the question and answer if you are not sure where to go. And I'm just going to put this in. X -5. Okay, so I have put that in. I'm going to look at the graph. Yes, my prediction was absolutely correct. It is upside down. It has flipped. And now I'm going to make another table here just so I know what points to do. All right, so it looks like 0, -5 is the first one that would fit on my graph. 1, 0, 2, 3, 3, 4. Now I'm looking at my y values and I don't see that pattern yet. That doesn't mean it's not quadratic. All it means is I haven't gone far enough to see that pattern. All right. I know for sure it is a quadratic because of that squared right there. Okay. So that square tells me, hey, this is for sure a quadratic. So let me keep going. So now I have 4, 3, and now I see it repeating. Okay. 5, 0, and 6, -5. All right. So take a minute. Again, you can pause. So 0, 1, 2, 3, 4, 5. Okay. 1, 0. I'm putting down now. 2, 3. 3, 4. Oops. Yeah. All right. 4, 3. And now it's kind of easy because I see where the other ones are, so I don't really even have to count. I just know I go 1 over, right? And then I go all the way down here. Okay. All right. So when I connect these, if I stop here, this is not full credit. You are actually graphing that over a restricted domain, which I don't want to do, right? So I either need to put arrows, or you could not put arrows, but then bring it all the way down. Okay. Oops, all the way. So yeah, okay. All right. So now let's see what this is. X-intercepts. All right, I want to see where y is 0. So here I have 5, 0. And over here, it's 1, 0. All right, so I'm just going to write that in. 1, 0, 5, 0. All right, let's get to that vertex. It looks like this vertex is a maximum. It is the highest point on the parabola. And that point looks like it is 3, 4. Right? The highest or the lowest is really a y value. So you're looking for the highest or lowest if it's a minimum. But in this case, the highest y value. So that is 3, 4. And then I can choose any old point. So I'm just going to put 6, -5, right? Because I just see it there. I could put anything, though. All right. Sorry about that. So questions, comments, or concerns, please, please, please write them down so you do not forget. I've done it so many times. First resort, always try to Google it and figure it out. You know, like sometimes if you go to different notes, go to different things online, type in what is standard form, what is vertex form. Sometimes you can figure it out that way. If not, we have a lot of office hours coming up. So just look at our schedule on Google Classroom, go to that question and answer sheet. And you will see all of our office hours, including me, Mr. Q, Miss Rebecca, and Miss Mock. All right, that's it. Thank you so much.